The control of an inverted pendulum. This is made by Team 4, made by Sunil, Moen, and Ahmad. A model of the inverted pendulum is made by balancing torques at the mean position. It is required to make a controller that maintains a constant, desired position of an inverted pendulum. The governing equations are converted to transfer function that can be controlled through various techniques for mankind. For this, our system requirements were our system equations, our system transfer function, and to choose the appropriate controller to achieve stability with minimum overshoot and transiting response. And our approach was the implemented proportional integral PI controller for the desired results. All right. This is the system modeling with its transfer function. I believe this was made by Moen. The system and inverter pendulum is attached to a motorized cart, and the purpose of the controller system is to stabilize the inverted pendulum by applying the force to a cart. Here we have our transfer function of output angle and input. We have our transfer function of current angle and input applied voltage equations. And then to the left, you see the system modeling. The system equations for a given system of an inverted pendulum actuated by the motor is shown below in the left two equations. And then the implementation of the PI controller in MATLAB is the PI is a proportional integral controller, and it's to stabilize the pendulum. The controller input is voltage VM. I believe the controller was done by Ahmad. And the outputs for like angular position of the pendulum and the horizontal position of the cart. Here you see the adjusted gains of the PI controllers by hit and trial method to get the desired result. And we've also listed our system parameters to our left. And this was done on MATLAB. All right, the results were also done by Ahmad. Below this are the values of KP and KI we had selected from MATLAB. It can be clearly seen through the response that the controller response has a minimum steady state error, but it has some oscillations and overshoot. When talking to our group member this and observing our analysis, it seems that it can clearly observe from the output performance result that the controller is tracking its reference nicely, but the expense of like the overshoot and undershoots. And we think that it can be enhanced still by adding like a derivative part. And then hopefully we can reduce some overshoots and undershoots. All right, so finally, the contributions for this project, it was 3 of us. There was Sunil, Moen, and Ahmad. I did the modeling transfer function, Moen did the controller, Ahmad did results, and then reports were made together. And this is Sunil speaking. I'd like to thank you all for your kind attention, and thank you.